Welcome to part 2 of the lesson on integration finding areas. The example that I'm looking at now is asking me to find the area of the finite region bound by the curve with equation y equals x minus 2, x minus 4 and the x-axis. Now, the first thing I'm going to do is I'm going to determine where is that finite region, and the way that I'm going to do that is by sketching the curve. Now this is a quadratic graph, so I can see from the two brackets that my roots would be at x is 2 and x is 4. So I'm going to draw that curve in, going through the roots x is 2 and x is 4. And hopefully you can see by that the region bound by the curve and the x-axis, the region contained is this one here. So I can see that I'm going to find that area by integration, and the limits I'm going to use are 2 and 4 because they're the numbers that the region goes between. So I use my integration symbol with an upper limit of 4 and a lower limit of 2. However, I cannot integrate this equation in this form because it's not number x power, so I need to expand those two brackets out, and that would give me x squared minus 6x plus 8 with respect to x. Again, I'm integrating x's. So we'll integrate that, so we get 1/3 of x cubed minus 3x squared plus 8x, square brackets, upper limit of 4, lower limit of 2. And then I evaluate for those two values and find the difference. So 1/3 of 4 cubed minus 3 lots of 4 squared plus 8 lots of 4 minus 1/3 of 2 cubed minus 3 lots of 2 squared plus 8 lots of 2, which gives me 64 over 3 minus 48 plus 32, which comes out as 16 over 3, minus 8 over 3 minus 12 plus 16, which comes out as 20 over 3, which comes out as negative 4 over 3. Now there's an issue here. Why am I getting a negative value for area? Well, the simple answer is it's because the area that I'm finding is below the x-axis. So the actual value of the area is 4/3. It's come out negative because it's below the x-axis. That's fine, as long as I'm aware of that when I work with these questions, and I know that if my curve dips below the x-axis it's going to come out negative. I can deal with that, that's fine. But let's just pause for a minute and think about why that happens, about what integration is actually doing. You may have done at GCSE estimating the area between curves and the x-axis by drawing simple shapes such as rectangles or trapezium. What integration is doing is it is finding the area of a series of rectangles to work out the area of this region here. And how integration works is it makes the width of these rectangles infinitely small so that we end up with the exact value of the area here. Now, if you think about how do you find the area of a rectangle, well, it's base times the height. In this case here, the height would be finding the y coordinate of where we are on the curve. Now, because it's below the x-axis, those y coordinates are negative. So the value of the integral comes out as a negative number, but of course because we know that we're using it for the purpose of finding an area, we take what's known as the absolute value, which is the number ignoring the sign, and therefore the area enclosed by this curve and the x-axis is positive 4/3. In the next example, we'll look at how to deal with when you have two different sections, one above the axis, one below the axis.